Hi, this is Mike and welcome to tutorial 6 on my series of writing a game on the iPhone. So this tutorial is going to be covering a tile map class. Now, as far back as I can certainly remember in games I used to play as a child, tile maps have been a very popular way of being able to display large playing areas whilst using less memory and giving you more flexibility. So the idea is really that you have a number of tile graphics and you use a sort of reduced set of tile graphic images to create large playing environments. And then as part of your game, you can scroll around those playing environments. So you could have a tile map which is using maybe 15 tiles, but the actual map that you create using those tiles is maybe 200 tiles wide and 200 tiles high. And as your player moves around the screen, you actually scroll that tile map around the visible area of the screen, so that you get the impression of moving around a much bigger game area than you've actually got. So the key thing here is that rather than storing a huge image of your playing area that's been pre-rendered, what you're doing is you're actually rendering real-time the image or your map on screen made up of small tile areas. So you haven't got to store this big image in the screen, you're just storing the representation of these smaller tiles, and then you're placing those tiles on the screen as needed. If you look online, there's lots and lots of references to tile maps and what it means, and why they were used way back in the day for old classic games, and also why even today on new hardware using tile maps is a great idea. It solves a number of problems, not just moving large areas around, but collision detection can be enhanced or simplified using tile maps and so on. So it's an important part of having a game engine, and certainly as I've looked around to sort of identify all of the elements I would need to develop this game, it's been obvious that having a tile map implementation is going to be important. So what we've done is I've gone and had a look around the internet and identified a tile map editor, which is obviously a bit of software that lets you edit tile maps and lets you use them to, lets you use the software to create your tile maps, which are then processed by your game. So the tile map editor that I have found is one called TileD. So the TileD editor is a free download. It's a Java application, so it'll run on any platform, and it's something that I've used in the past to create simple tile maps. And because I've used it in the past, I decided that this would be the application I would actually write my class for. There are other tile map editors out there. There's Mappy, for example, which is another one which I think people use quite a lot, but TileD is the one that I had some experience with, so that's the one that I'm using. So what I'm going to do is I'm just going to fire up TileD so you can have a look and see what it looks like. So this is the basic editing screen. You have an area at the top which is where you will actually edit your map itself. Then you have a tile palette, which is where you will actually load your tile sets up. And then you have a layers section on the right, so you can have multiple layers inside your map. If I load up a test map that I've just thrown together, that'll give you an idea as well. So you can see in loading my map, I've now got the starts of a tile map in this top area, and you can see I've got some very simple tiles down here in the tile set that I've loaded. If I zoom out of this tile map, you'll actually start to get an idea of what it looks like. So this is a big area of map. This actually is around about 10,000 tiles per layer, or 10,000 squares per layer. And rather than storing that big image as a texture, the only images that I'm storing are just these few simple images down here in the tile set. And what I do is, if you want to design and draw your tile map, all you do is you select the tile you want to use, and you go in here and you start drawing and identify how you want the map to be. So that's it. That's how simple it is to create your tile map. So what my tile map class does is it takes the output from your editing in this program, which is an XML file, and it takes that file, reads it in, takes the tile map image, reads that in, and then through a very simple API is just allowing you to render this map to the screen based on, for example, an X and a Y coordinate. So you you specify an X and Y coordinate within the map. You then specify a screen coordinate on the screen and tell it to render. And we'll be going through obviously how that works. But this is the editor. It's quite a useful editor. It's recently had some bug fixes and some changes made to it, so it is getting some attention. It's not a dead project. If I have a look on the internet, there is obviously a website for it, which is mapeditor.org, and here is where you can find information out about the actual editor itself. You can find out some information around the documentation. So if I actually just go to the main page, here we go. So you can see that the last piece of work done on it was November 30th, where they made some fixes and they made some changes to it. So this is the website. So mapeditor.org is where you can go and download this, and it's all open source, so you can actually see the source code as well if you're interested. But it's what I'm going to be using throughout this tutorial to power, or to at least generate the file which is going to be consumed by my tile map class. So I'll just get that out of the way. So that's the editor. There are a couple of things to note before we get started on here, in that when you save a file from tile D, there are some properties that you can define. So if I just have a look at those properties inside the saving tab, you can see here you can actually encode the output in as binary, and if you do encode it as binary, you can press it as gzip. I had a quick look at how I could actually process data that had been gzipped and unzip it and use that, because obviously it does mean that the tile map files are much smaller. I must confess I didn't get anything to work, so what I've done is I've switched these options off at the moment, so you can see all of these options are switched off in here, and it means that I just get a straight text XML file, which is going to be, for a large map like this, 10,000 tiles, and there's 2 layers, so 20,000 tiles is about 300k. So it's a fairly big file, but to be honest, 10,000 tile map is that's as big as you're probably going to want to go on the iPhone. I would suggest that certainly with the class that I've written, that's also that is pretty much the size you want to go to, and we'll talk about why later on. So just remember those settings. You have to have everything in here turned off, because that's the format that at the moment the tile map class can actually handle. Okay, so that's tile D, the actual editor. So what we'll do now is we'll jump in and actually start building this tile map class out in our project. So I'm carrying on from tutorial 5, and we'll just add to that project as is necessary. As part of doing the tile map work, I have made a few little changes to some of the other classes as well. So for example, I've made changes to the sprite sheet class. So before we start diving in and actually creating the tile D class itself, I'm just going to make those changes to the sprite sheet class. So selecting the spritesheet.h file, what I've done is I've actually added a couple of properties here and removed a couple of methods. So the properties that I've added, I should pop in here, and these properties are used to hold how many horizontal tiles, how many horizontal sprites there are and how many vertical sprites there are in our tile sheet. So what I'll do is I've got one and I'll call it horizontal, call it count, that'll do. That's going to be an integer, and I'll call it horizontal, and then we'll do one the same, and it'll be for vertical, like so. Now down inside the methods, there are 2 methods at the moment called horizontal sprite count and vertical sprite count. These are doing the job that I'm going to do now earlier, but I've just changed them to properties, because once they're calculated, you don't really need a method to go and do anything. It's a bit of overkill. We can just access the properties. So I'm going to get rid of those 2 methods there, and the other thing I need to add are the actual property definitions in here. Now these are read-only because they're calculated basically when you instantiate your sprite sheet class, and because they are created like that, we don't really want anything to change as we're going through. because it's defined. You've given a sprite sheet, you've identified the size and width of the sprites, you've given it an image of which your sprite sheet is to be used, and therefore you don't really going to change it unless you were changing the image. But for the moment, we're going to leave that all as read only. So I'll save that, and we'll now quickly drop into the spritesheet.m file and make the changes in there that are necessary. So what we need to do first is add those two properties and synthesize them. So we had horizontal and we had the vertical, like so. And the next thing that we need to do is drop down to our implementation here, and I'm just going to drop in the lines that are going to be used to calculate the horizontal and the vertical, like so. So for the horizontal, we're taking the width of our image minus the sprite width, and we are dividing that by the sprite width plus spacing, because there could be spacing between each sprites, and adding 1. So that's going to be our calculation for how many horizontal sprites are there based on the width of a sprite and the width of our sprite sheet itself. And then we do the same for the vertical side of things, except on the vertical side of things we check to see if we've hit a fraction. So if we've hit a fraction rather than a full number, we just add 1 to the vertical count to make sure that we actually do get the right count inside the calculation that's in here. If we scoot down inside the method, you'll see that we've got our horizontal sprite count and our vertical sprite count, and you'll recognize those calculations. They're exactly the same calculations that I was putting in up above. So all we've done is literally move them from these methods and place them into the property calculations during the initialization of the sprite sheet. So what I can do is I can actually remove these from here, like so, because they're no longer needed. So I'll save that, and I'll do a quick build to make sure that everything works there. Okay, so not introduced any errors at the moment. So that's our quick change on the sprite sheet. So that's now been updated. So what we need to do now is we need to actually add some code which is going to handle our XML parsing. This has been an interesting journey for me. I was expecting the iPhone SDK to have a lot of information in it, or sort of a lot of capabilities in it to handle XML processing. Just like the normal Mac SDK, which has got NSXML document and NSXML parser and so on. It's basically got a large API for handling XML documents. On the iPhone, they don't exist. The only thing that does exist is NSXML parser. So I had a go at using that first, which is a sort of an object-oriented way of doing it. Basically, as you parse an XML file, every time you come across a brand new element, it fires a target method inside a chosen delegate. And then inside there, you would have to have all of the code which says, well, depending on the element which I've just started, what am I going to do with it? It also does the same when it comes to the end of an element, etc. So it actually didn't take long to get it up and running, but it was really slow. I mean, it was extremely slow, too slow to use. And it also seemed to consume an awful lot of memory, which, having had a look around the internet, does seem to be an issue that exists with NSXML parser. So I had a look around to see what else I could find, and obviously it looks like there's a lot of other people who are having the same issue with wanting to process XML on the iPhone. So first of all, I tried something called Touch XML, which is a C wrapper around the libxml2. And again, from what I've been discovering, libxml2 is an open source XML engine which is actually used by Apple. It appears to be what is underneath NSXML in their API. So I tried Touch XML, but because I'm using XPath, or I wanted to use XPath to go and grab information from inside this XML document, I found a bug, which was that it just would not process all of the XPath I was providing it properly. So I had to give up on that, which was a shame because the actual parsing was extremely fast compared to NSXML parser. But what I did come across was something called Kiss XML, which is very much based on Touch XML. And what it does is it tries to replicate the NSXML API that Apple provide by providing a C wrapper around the libxml2 library. So this one again is quite handy in that the documentation for NSXML is actually valid for this library as well. So you can look at the NSXML functions, and this library will support most of them, not all of them, but all of the key things that I needed were there. And also it has the advantage of not only being able to read XML, but also to write XML. Touch XML actually only allows you to read and not write. So this is a slightly better engine, or slightly better library from that point of view. So that's the library I'm going to be using, and there is a little bit of configuration that we need to do to make sure we can actually use that library. So the first thing that I need to do is I need to make some changes to my target here, and make some configuration changes to the build properties. So I'm going to go into my build properties window, which has actually appeared on a different screen, so bring it up here. And there is an area I want to go to, which is called other linker flags here. And so this other linker flags entry I want to add to that. So double click the line and hit the plus button, and I want -LXML2. Now these are instructions that I got from the KissXML websites. Okay, so if you go to their website, which we'll look at in a moment, you'll see the instructions and what you need to do to actually do this configuration work. So you add the LXML2 linker object like that, and then we search for the next parameter we need to change, which is the header search paths parameter. There it is, just here, and we need to edit that as well. So again, hit the plus button again, double click in here, and that should be /usr/include/lib xml2. Okay, so that's just so that it knows where it's going to find the libxml2 files that are needed by the KissXML API that we need. So they're the two things that we've set. Now, one thing to be aware of is I've gone and done that inside all configurations. Something that caught me out is that I went and made that change in just debug, and then when I came to try it under the release, then you just get loads and loads of warnings and errors when you try to compile. So by making those changes under all configurations, they apply to both debug and release, so something to be aware of there. Okay, so I'll close that down. And what we now need to do is we now need to get the code and actually bring across the KissXML code. Now if I go back to the browser here, and I've got the KissXML Google Code page open, so you can see here the address, code google.com, p, and then KissXML. All the information that I needed to basically get this up and running was off of these web pages. So again, you could use these as reference as well if you need to. But if I click on the source, you'll see here that there is an SVN. So there's a subversion which you can use to actually grab the source code. So what I did, I actually put that configuration inside the source control side of Xcode. Which first time I've done it, but it seemed to work pretty well, which I can quickly show you now. So inside Xcode, underneath SCM, there are some repository settings, okay, and you can configure the repositories. So if we look inside configure, you'll see I've got a couple of different repositories I've set up in here. One I did for TouchXML when I downloaded TouchXML, and here I've got one for KissXML. So all I did was I hit the plus button down here to create a new repository. I gave it a name, and I just copied and pasted the URL in here. And when you do that, it fills out these other areas for you, and then it will authenticate and give you a green light if everything's okay. Once you've done that, you can hit OK, and that means you've set up that repository. To get access to it, if you then go back into SCM and look in the repository side of things, what you'll see here is a list of the repositories that I have on the left-hand side. So I've already got the KissXML repository selected, and you'll see that it's actually gone in there, logged in, and is now giving me a list of all of the files that are available inside that particular repository. So what we'll do is we'll flick back to, I'll kill that, and then we'll flip back to Xcode here, and we'll just add a new group, and I'm going to call this new group DDXML. Okay, because this is the name that I've seen used elsewhere in some examples. So DDXML is also what is used for the command. So it's DDXML document or DDXML element. So I'm going to use DDXML here. And I need to grab in there what is inside that source code management tool. So all I've done is from inside repositories, was I highlighted the DDM-XML document all the way down to node testing, and also included the string additions.h and .m file. So they're the only files you need to actually download. Now, for some reason, and I think it's because there's no directory above this, the checkout button doesn't highlight on here. So what I did was I created a directory on my desktop, and literally I just highlighted these files and dragged them across and dropped them. And then in this bottom window, you'll then see that it copies them and actually checks them out into that directory. So then have your own local copy of these elements. So I've already done that. So what I'm going to do is I'm going to add those files now. So by doing a right click and choosing existing files, you can see here I've got a directory called KissXML, which if I open it, you'll see they're the files that I just said that we needed to download. So I'm going to highlight all of those, select add, and I'm going to ask for them to be copied into my project so that they're there. Okay, and they're copied across. So there we go. That's all those files now in that particular directory. And what we can do is just to make sure that that's come across okay and that our project settings have taken okay, is we could just compile this and see if everything compiles okay. Yep, there we go. So we've compiled that, build view, and we don't have any errors come up. As I say, if you get loads and loads of errors coming up, then the chances are that either the other linker variable or the header search path setting inside your target here, which we set earlier, haven't been set properly. They're not stuck for some reason. So check those and make sure you've got them on all configurations so it's applied to everything. So in terms of actually configuring KissXML, that's it. It's in our project now. It's ready to use. So what we'll do is we'll start now to create the actual tilemap class, and we can then use the DDXML in there, and I can show you how we run through that. Okay, so what I'm going to do is I'm going to create inside our little engine folder here. I'll just close the animation. I'm going to create another group inside the engine folder, or the engine group, and I'll call it tiledmap. Okay, so we understand what it is. And we need to create 3 objects in here, which we're going to be using. The first object of type NSObject subclass is going to be called layer. Okay, the next object that we want to create is the same type, so we're going to continue to use NSObject subclass. And this one needs to be called tileset. And lastly, we are going to create one which is going to be the actual core class. Oops, selected the wrong option there. New file. And this one is actually going to be called tiledmap. Okay. So what I'll do is I'm going to go through these in reverse order. So I'm going to actually run through these, starting with the layer and then tileset and then into tilemapd, which is our main class. So if I start with layer first, what the layers are, as you remember from when we actually had a look inside the editor, you can have multiple, as many layers as you want on a map, which is really good for being able to layer objects. So you could have your core, you could have the ground laid down first, so grass and stone and everything else. And then if you wanted housings and buildings and other objects to be layered on top of that, you could create a separate layer and then apply tiles over the top of the tiles that are already there that have got transparency. So you can see the underlying tile come through from your first layer, but then you're using your second layer to apply different items as well, or different objects to it. So you can build up your map using these different layers, and when you render you can say which layer do you want to render. Do you want to render all the layers, or do you want to render just one layer, and so on. So you have the ability to be able to set that kind of information. So what I'll do is inside here I'm going to paste the layer information. So what we've got defined here is we've got a maximum width and height for a layer in tiles. 500 is a pretty big number. If you wanted to go bigger than that, you would need to make changes here, but 500 is a fairly big number for 500 tiles wide, 500 tiles high. So 500 is what I'm using. We then define a layer ID, so every layer has an index or an integer which is its identifier, and it has a name, and the name is actually read from the XML file which is generated by TileD, the actual map editor. And then we have an array, a very simple array, so we're not using an NS data, an NS array or an NS mutable array. We've just got a simple array of type of integers, and it's a multi-dimensional array, so it's 3 dimensions here. The first dimension is covering the width of our map, the second dimension is the height, and the third dimension is the type of data that's going to be stored. So you'll end up with an X location, a Y location, and within that you're going to have 3 other points, or 3 other holders of information, if you like. These are defined here in the notes that I've typed up. So in position 0, it will actually identify a tile set ID. So you know what tile set the tile in that location belongs to. You'll then end up with the tile identification, so the tile ID number for that tile, which is within the tile set that has been selected. That's the tile number that should be rendered. And in the third location, or index 2, you'll end up with the global ID. Now, this can be a little bit complicated and take a while to get your head around, and there is more information, although it's not a lot of information, on the TileD website. But basically each tile set will have a set of tiles, and those tiles will be numbered 1 to however many tiles there are in the tile set. If you then have a second tile set, that will also contain tiles numbered from 1 to however many there are. So to uniquely identify tiles from different tile sets, when you create a tile set, whatever the last tile ID number was in the set previous to the one you have just created, so for example, say my tile set 1 has 6 tiles, there will be a first global ID reference created when I introduce a second tile set, which will say 7. Which will say 6. So it will basically be saying this is the number of tiles in the previous tile set, and so the global identification for tiles inside tile set 2 will now be that number, first GID, plus whatever the tile set number is inside the second tile set. So 6 plus 1 is 7, so the very first tile inside the second tile set will have a global ID of 7. It will have a tile set ID of 1, but it will have a global ID of 7. Okay, and that's how you can have multiple tile sets using different images, if you like, sprite sheets, but you're going to be able to reference each of those tiles using its global ID. Okay, so that's how it handles it. Because if you had, as you can imagine, if you had 2 tile sets, they each had 6 sprites in them, 6 tiles in them, and you selected tile set 1 and you went into your map and you put the tile down, which was tile ID 2, and then you selected the second tile set and also went and put down the second tile in the map, it doesn't know from that what the actual tile set is or what the tile is inside the tile set, so it gets confusing. So they've approached it, the TileD format approaches that by this global ID, and I hope that's made sense and you've understood that. So that's the data that's stored. So this really is the underlying data structure which holds all of the tile information. A layer has an X and a Y, and then the tile information about what's inside that location. We then have the width of the layer, the height of the layer, as you can imagine, and then we have a mutable dictionary of properties. So for the map itself, for the entire map, and for each layer, and for the tile sets and the individual tiles within the tile sets, you can have properties, which are user-defined name-value pairs. And again, when this particular class reads in the map data, it can read in those properties. So you can then query those properties. So you can store useful information that the game may need to know about inside either a layer or a tile location or the overall map itself. So for the layer, we've got a mutable dictionary which is going to be storing the properties for this particular layer. So I've then gone and defined the properties that we've got. They're all read-only, apart from the mutable dictionary one, because that will actually be added after we have created an instance of layer later on. And then we have a set of tasks. We have an initializer, which allows us to initialize a layer, giving it a name, giving it an ID, a width, a height, as you would expect, because they are the properties of a layer. We can then add a tile. Okay, so what we're going to do later on is we'll see that we actually create an instance of a layer, and then as we identify tiles inside our XML file, we add those tiles, okay, to this array just here using this method, add tile at X, Y. So we say for the X and the Y location, for this tile set ID, for this tile ID, and for this global ID, that's the value I want you to load into that layer. We then also say another method here, which is get tile set ID at X. So that is going to allow us, sorry, an X and Y. That's going to be able to say for this tile set, for X10, say, and Y10, go and grab the tile set ID for that particular tile. So we can see what tile set that tile comes from. We can then do the same and get the global ID at an X and Y coordinate, and we can then get the tile ID at an X and Y coordinate. And they're important because we need to do that when we're actually rendering the tiles, so we know what tile set to use, and therefore we can identify inside that tile set what tile needs to be rendered to the screen. So that's really everything inside the layer.h file. And if I look inside the layer.m file now, I'll just paste in the information that's needed in there. Okay, so there we go. So all I'm doing is I'm synthesizing those properties which we've defined on the previous page. I've got my initialization routine, which takes in, as we said, name, layer ID, etc., and just sets them to the local properties which we've defined. And then I have my 4 other methods. So get tile ID at X and Y is very simple. Layer data is the array that we've created. So what we do is we say, okay, go into the layer data array, the multi-dimensional array, at location X and Y, which has been passed in here, and retrieve for the 3rd dimension location 1. And if you remember from the previous screen, if I flick to that, location 1 is getting us the tile ID. So that will then pass back whatever the tile ID value is at that location. We then do exactly the same for getting the global ID, okay, but we pass back location 2 in there. And for the tile set, we do the same again, except we're passing back location 0. Okay, very simple. And last of all, we have the add tile method, which is saying this is the X and Y location, and at that location inside our layer data, we want to set this tile set ID, this tile ID, and this global ID. Okay, which you can see is being set here. And that's it. That's our layer class. So that's what a layer object looks like and how it's going to store its data. So I'll save that along with the header side of things, and then we'll move on to the tile set. So just like we've got a layer object for each layer in there, as I've already mentioned, we can have multiple tile sets. So again, for each tile set that's identified inside the XML file, we will create an instance of the tile set class. And this is the detail. So we have a number of items in here which we need to store. Now, first of all, we're importing the sprite sheet here, which is important because basically tile set is going to use a sprite sheet because we're going to be reading in an image which is identified inside the tile map data file. And that image is going to be then chopped up into tiles, okay, exactly the same way as we've dealt with sprite sheets in the past. So we're going to reuse the sprite sheet class inside tileset to manage that for us. We then have the tileset ID, the name. We have this first GID, okay, which is what I was describing earlier. This is the global ID that is going to be added to all of the local tileset IDs to retrieve the global ID. Sorry, that's the first ID, not the global ID. So the first ID will be added to the local tileset IDs, which will then give us the global ID. We also have last GID, which is identifying what's the last global identifier we have in this tile set. We then have the tile width and tile height, which we can use inside sprite sheet to be able to chop up the tiles. Spacing again is the same thing. We can chop up the tiles and introduce spacing if we need to. We're identifying a sprite sheet, which we're calling tiles, as you would expect. We then have a horizontal tiles and a vertical tiles property. So that's again, how many tiles are there wide and how many tiles are there high. And then we have a tile set properties, which again is another mutable dictionary. Because just like layer and map, you can have properties, name value pair properties that you can define for a tile set, all the way down to each tile. So an individual tile can have any number of name value pairs, storing useful information that you may want to hold in the map. The next step is that we just set the properties in here. Again, they're all read-only apart from the dictionary, which we're retaining because we want that to actually handle retaining and releasing memory as necessary. And then we have 4 simple methods. One of them is the initializer. So we initialize an instance of tileset, passing in all of the details that that we need, as you can see here, so name and tileset ID, etc. We then have one method here called contains global ID, and this is quite a useful little method because when we're searching through tile sets, we're not going to know just by looking at the tile set itself what global IDs it contains. So what we can do is we can say for a global ID, we can pass it into this method, and this method will then come back and do a very quick check to see whether or not the tile set, this particular tile set contains that global ID, and it will pass back a yes or a no. We then have got 2 methods here, one saying get the Y coordinates for a particular tile ID, and the other one saying get the X coordinate for a tile ID. So if we've got 6 tiles and you send in a tile ID of 3, okay, which is something that could quite easily be done, you want to be able to get the X and the Y coordinates from that so that we can extract that tile from our sprite sheet. So these 2 methods are used when rendering to extract the right image from our sprite sheet for a particular tile ID so that we can render it on the screen. So I'll save that, that's our tile set header, and that just leaves us the .m file for us to have a look at. So we'll just paste that in here. So again, just as before, I'm synthesizing the properties, pretty standard stuff there now that we've been through that a few times. Inside my initializer, as you can see, I'm creating a brand new instance of sprite sheet, passing in the image which has been sent to us. I'm passing in the width and the height and the space which has been sent to us as well. And for this, I'm currently hard coding a scale of 1. If we played around, we could probably change that and actually have it so you could scale the map up and down if you wanted to, but for this implementation I've stuck with a scale of 1.0. We then set the local parameters to be what they are, as in what they've just been passed in as inside our initializer. And you can see that for horizontal and vertical tiles, I'm actually using that new property which we created a moment ago inside sprite sheet class. Okay, so tiles is our sprite sheet, and I'm just going and grabbing the horizontal and the vertical properties from that to set these 2 values here. Last GID is being calculated by multiplying the number of vertical tiles that we have by the number of, horizontal tiles by the number of vertical tiles, and then adding the first global identifier -1 to that. Okay, so we know what the first global ID is here because it's actually being defined. So that will then mean that we know the first, so we then, based on the number of tiles that are in our sprite sheet, we calculate the last using that little equation there. We then set the height, width and spacing just as you would expect to set the local properties based on what's been passed in. We then have the few methods that we have in here. So the first one is that contains global ID. Which, as you can see, it's a very simple check. We are literally saying if the global ID is greater than or equal to the first global ID in this tile set, and it's less than or equal to the last global ID in this tile set, then it must be in this tile set. So that would return a yes. If either of those things aren't true, then it would return a no. For the get tile X, we're saying, well, if we pass in that tile ID, we actually use the modulus operator here, the % here, which gives us the remainder. Okay, so it will be the tile ID divided by horizontal tiles, and whatever the remaining value is of that is what that operator is giving us, is what is the tile ID as an integer. And then we're doing a similar thing for the Y. We're saying pass in the tile ID and divide that by the horizontal tiles as well. Okay, so we're using horizontal tiles in both here. And by doing those simple little calculations, it will actually give us by just knowing the tile ID and X and a Y coordinate into the sprite sheet. And then lastly, as you can see, we've obviously got the dealloc where we release our tiles, and we also release our tile set properties, which are immutable array. So anything that we allocated, in other words, which consumed memory and that we're responsible for, we release, so that when this is released, then that memory is released as well. So I'll save that. So that's our layer and our tile set classes sorted, and that leaves the actual core tile map class now. This is going to be doing all of the work of actually parsing our map file, as well as then rendering the map file, etc. So what I'll do is pop that code in here. Now this is a fairly chunky class, so I'll go through it at some speed. Hopefully it won't be too fast, and you'll be able to catch an eye of what's going on. And I've also stuck a link here to where you can find tiled as well. But if we have a look, just like the layer and the tile set, a map has a set of properties to it. So we grab things like the width, the height, the tile width, the map width and height, that is, the tile width and height. This actually isn't needed anymore. I can actually get rid of that. We're not using NSXML parser, so that's a bit of an artifact I can get rid of. Save that. We've got the current tile set ID, which we're going to be using. We've got the tile set itself, okay, which is an instance of the tile set class we've just been creating. We then have the current layer ID. We then have the current layer, which again is an instance of the layer class we've just created. We then have an array. So inside each map, there's going to be an array of tile sets and an array of layers, okay, because you can have multiple tile sets and multiple layers. So we're setting up an immutable array of those. Because again, we don't know how many there are going to be until we start processing the map configuration file. And then we have the two dictionaries. So we're going to have map properties, which is going to be a dictionary, and we have tile set properties in here as well. We then have a number of IVARs which are going to be used for our tile set. So as we're processing our tile set, I'm using some variables here to grab the tile set name, ID, width, etc. And again, the same for layer. Okay, so these are all going to be used internally. So not all of these will be exposed to the outside world. A lot of these will actually just be used internally while we're processing the map file. And then lastly, what I have here is, let me see if we're flicking around a little bit there, is I have the vertex array. So this particular class is going to be responsible for rendering a tile map. So I'm using the GL draw elements side of things. So I'm using vertex arrays to actually do the drawing. So I can actually just define all of the quads that I want to draw, all of the textures that are going to be associated with those quads, and just say in one command fly it all down into OpenGL, so OpenGL can process it much more quickly. The same approach that I was taking when we did the angle code font. Okay, so we're reducing multiple calls to draw to a single call to draw. So code is exactly the same as we've had before. I then expose a number of properties which are read-only: map height, width, and then tile width and height. And then we've got the methods which are going to be exposed for the tile map class. So as you would expect, we've got the ability to initialize an instance, and what we do is we pass in the file name and the extension of the file that is going to be the control file for our map, so the configuration file. Normally it's a .tmx extension, but you could change that if you wanted to. We then have a method here which allows us to find the tile set with a global ID. So by just passing this a global ID, it will search all of the tile sets that are defined inside a tile map and come back and tell you which tile set contains that global ID, which again is a nice convenience method that we can use while we're rendering. We've then got the render method, which takes a few parameters here. The first parameter point is going to be the location on the screen where we're going to start rendering the map. The map X and map Y is actually the X and Y coordinates within our tile map that we're going to start rendering from. Width and height is from this X and Y location, how wide and how high do we want to render. Okay, so you could say, from the X and Y location I've provided, I only want to render 2 tiles wide and 4 tiles high. Okay, so you don't have to render enough tiles to fill the whole screen. You could actually render just a subset of tiles if you wanted to. We then pass in the width and the height and the layer ID as well. So, sorry, the width and the height just talked about, which is the width and height of the map you want to render. And then we pass in the layer ID. So if you have multiple layers, you could say I want to render layer 0. You could then render layer 1 in a separate call and so on. My plan is that I'm going to change that. So actually you could put in here, say, for example, -1, which would then mean it renders all the layers automatically for you in one call. At the moment, I've got it so you actually render each layer by doing a separate call. You can then get a particular layer name, get a layer by using its name. So you can get an index for a layer by using its name that's been defined. And then these last 3 are all about getting hold of property values. So if you want to get hold of a property that's been defined at the map level, you'd use get map property and you'd pass in a key, which is a string. And you'd also pass in a default value. And the reason for that is if you actually pass in a key and it comes back and it's unable to find the key or it's empty, then it will actually pass back whatever your default value is that you've got here. Okay, so that's the default value that will be passed back. Same for getting a layer property, and pretty much exactly the same for getting a tile property. So with the tile property, what you're doing is passing in one of these global tile IDs. And once you've done that, you're then telling it the string, because remember, each tile can have its own set of properties. So you're identifying a tile first, then identifying the key you're looking for in the property within that tile, and defining a default value on top. Okay, so that's the header. And now we've got the guts of this. And as I said before, this is quite a big class here, because we're actually doing quite a bit of work in here. So I'm going to paste this in. And off we go. So what I've got here is I'm defining at the top here a private method called parse map file. So I'm not exposing that outside a tile map. That's because I'm only going to be using it myself internally. And I then synthesize, wrong word. I then synthesize the properties that I need to expose here. So map width, map height, tile width, tile height. And then I initialize. And this is quite a big initialization routine here. So remember, I'm being passed in a file name and an extension, which is the name of the configuration file that is to be read and is to be processed. So once I'm inside here, first of all, I allocate my mutable arrays for my tile sets and my layers. I then go and grab basically the file that is the configuration file, and I load all of the contents of that file into a string. Okay, so I do string with contents of file, and then I use the NS main bundle, and I go and grab the resource path for my tiled file, which we've got up here, and I then also pass in the extension. So once it's found that file, it will go and load the contents of that file into this long string, so you have a big string in memory. Once we've got that string, we then parse it. Okay, so here we have the ability to go and parse that particular string using that, parse that file using the string we've just created. So what I'll do is I'll scroll down and we'll look and see what the parsing is doing before we continue with the initialization. So inside the parse map file method, we're passing in the tile.xml string, which basically contains our entire XML document. And what I do in here is I go and allocate a mutable dictionary for our map properties. I also go and create an error object here, this NS error object, and set it to nil. And what I do is when we call any of our XML commands, you can actually ask any errors that arise to be placed inside this particular variable, which is what we use it for. We then set a couple of counters and control variables here. So our current layer ID is 0 because it's the first time we've gone through. Same for our current tile set ID is 0. And our tile X and our tile Y is also set to 0, and we'll be using those later. And then we start getting into all the XML side of things. So the first thing we do is we create an instance of DDXML document, which is almost identical to NS XML document. And that's what I quite like about this API, is that it does follow the method names and functions that are inside the NS XML API that Apple provide. So this is really, in my mind, giving the iPhone the missing XML functionality that isn't inside the SDK. I'm not sure why they've not got it in the SDK, whether it's that processing XML is quite a heavy piece of work and therefore it would drain the battery because it's a lot of CPU work. I don't know. I'm not quite sure what the reasons are, but anyway, they don't include very much in the SDK. So this Kiss XML is a great little library which I think I'm going to be using for quite a few little projects. So what I'm doing is I create an instance of this DDXML document, and all I do is I allocate it, and I'm saying I init with a string, and the string I'm passing in is that string that we've just created, which are the contents of our XML file. And if there's an error, I go and drop the error into the error variable that I've just created. Yeah, that's right. The next thing that we do is we then start processing the data. So that from my XML document, which is just here, I go and create an array, and I call it map elements. And what I do is inside my XML document, I use nodes for XPath. So I'm not sure whether you'll be familiar with XPath. Again, there's some great tutorials out there. Most developers now have had to use XPath and XML in one project or another. But there's lots of information out on the web about XPath and how to use it. But what I'm basically doing is I'm passing in an XPath expression here, which is /map. And that's actually basically bringing back all of the elements that exist within my XML structure underneath map. And if there's an error, I then pass it out here to error. Once I've got hold of that, my assumption is that for this to be a valid map file, there's only going to be one map element, okay? And so what I do is I go and grab the first entry inside my array here, which should be my map entry, and then I go and identify and set the values for things like map width and map height. Now if we actually have a look inside one of these files, which I haven't got loaded in here at the moment, what I'll do is I'll actually quickly add some existing files. Okay, if I look inside graphics, I've got a test map here along with the PNG file which is used for its tile sets. If I add those to my project, okay, and copy them across, if I select my testmap.xml file, you'll see here this is the XML that's inside one of these map configuration files. So you'll see that map here, my map element, has got a number of attributes, okay, inside that particular element itself. So what I want to do is I want to go and grab the width and the height and the tile width and the tile height and load these values into variables inside the class itself. And you'll see that tile set has got a number of similar attributes as well, as has layer, as has the actual tiles themselves. So that's what the XML looks like, and to do that what I can use is I can use this attribute for name. So I can take the map element, okay, which I've just defined as being the first entry inside my array that I created, and I can use the attribute for name method, passing in the name of the attribute that I want, and I can ask for the string value back, okay. And in inside XML, these are always going to be string values, certainly inside the map configuration file. So because of that, I'm actually then saying, and I want it to be returned as an int value as well, okay, because map width and height are integers. So I do that for all of these useful pieces of information that I'm going to need, and then I just output a couple of logs. So you'll notice on the log output on the console that I do output quite a bit of debug info on tile D, so you can see what it's read in from the XML file. If you want to turn it off, you just need to go in and remove these NS log entries. So once we've done that, we then start processing the properties for a map. So again, what I'm doing is I'm saying, well, inside the XML document, I'm going to use an XPath expression again to get map properties property. In the example we were just looking at, we didn't have any properties that were defined. But what this would do is it would say, well, for inside a map, there are going to be properties, and inside properties, there is going to be a property tag for each property that's defined. So this will create another array of anything inside any elements, sorry, inside our XML file, which are inside this location, okay, which is almost like a directory structure. Once I've created that array, I then just do a loop around all of the elements inside that array, grabbing the name and the value pairs for that property. And as I grab them, I then go and add that name value pair using the name as the key and the value as the object inside my map properties, which remember is a dictionary, mutable dictionary. So that's how I grab the properties, and I then move on and I start to do the tile sets. So again, I use exactly the same functionality as before to go and grab the tile sets. There may be multiple ones of them, and because there may be multiples, I then use a loop to go through grabbing the attributes that are necessary. For a tile set, once I've grabbed the attributes, I then want to go and look at the source, and the source is basically the image file which is going to be used for this, so the sprite sheet which is going to be used for this particular tile set. So I grab that, and I then inside that look at the tile attributes, and this is where the properties, so tile set properties are defined here. Okay, so again, I use this piece of code to go and look through, and I'm not going to go through it in detail now. I think you get the idea, and you can look at the source code yourself and sort of see how I've pulled this together. But this will actually go through and grab the properties. And once we've done all of that, so we've gone and processed all of that information around a tile set, we then create a brand new tile set instance using all of the information that we've read. We add that tile set to our tile sets array, okay, because a map can have multiple tile sets. We release the current tile set, ready to then recreate a new instance of it for the next time round, and we increment the number of tiles that we have. Okay, and then we go round again, and if there is another tile set element, it will do the same, so we can process our multiple tile sets inside our file. Once we've done our tile sets, we can then go through and do exactly the same for layers. So very similar information, looping through in exactly the same kind of way and grabbing the properties in the same kind of way. And again, once we've done all of this information and we've created our layer, which we're doing up here, we're creating our new layer instance just here. We then identify the actual layer data, which is for each tile, okay, identifying what the tile ID is, the global tile ID is for that tile. So this is where we start to loop through as well. So we basically say that while we're hunting through for the tiles, we say the X and the Y coordinates are zeroed, okay. We create a new array, which is getting us all of the tile information inside our layer. And then for all of the elements that we find, we loop through. So we basically loop through all of those elements, grabbing the global ID for that particular tile. And then this is where we're saying we add the tile. So remember, we had an add tile at method inside our layer object class. We actually say for the current layer we're processing, we want to add a tile, and the tile is going to be at the X and the Y location that we've defined. And sorry, let me rewind that slightly. If the the global ID is 0, it means there is no tile in that location. So what we do is we just set a default value for that particular tile inside the layer. So we say a tile set ID of -1, which later on, if we come across a -1, that's not a valid tile set ID, so we don't bother processing that particular tile. If the global ID isn't 0, which means that it is a valid tile entry, we then create a brand new tile set instance, okay? And what we do is we use the find tile set with global ID. So this is the other one that we created. So inside tile set, there is this find tile set with global ID. Inside the map class, there is this find tile set with global ID. So what we do is we pass in the global ID we've just identified, and this will then go and work out what tile set that's in, because we've already gone through and worked out all the tile sets in our map class. So by doing this, we then are able to understand what are all of the, we're able to loop through, all of the tile sets that we've identified and work out which tile set this particular global ID exists within. Once we've done that, we then add to the current layer our tile using an X and a Y, okay, and you'll see that we're incrementing them a little lower down. We now know the tile set ID. We then calculate the global ID, okay, the tile ID from the global ID, and then we set the global ID as well. So this sets up in our layer, this is adding a tile to our layer basically. Once we've done that, we then increment X, okay, so we move to the right because we're going through the tiles from left to right, top to bottom. If we've now got to the width of our layer, -1, because it's 0 indexed, we then reset X and we increment Y. And this is how we're calculating the X and the Y locations of our tiles from within just a straight linear set of data inside our XML file. And we just keep looping through all of those tile data. Once we've done that, we've got a complete layer object. So what we do is we add the layer that we've just created, which is current layer, to our layers array. We release it as before and we increment the number of layers we've got. And then we loop around again, okay, just in case there's another layer we need to process. Whew, dear, that's quite a bit there, isn't it? And once we've done that, we're finished processing the map file. So we can release the XML document. We've now got an instance of tile map which contains everything we need from our tile map configuration file, all passed nicely for us. And that allows us to move on to the next set of methods which I'm going to run through. So the first method here, or this next method should I say, the find tile set with global ID, this is one we mentioned earlier, and what we want to do is pass in a global ID and then search through all of the tile sets. Okay, so we go through the tile sets that are inside our tile sets array, and we then identify whether or not that particular global ID exists in that tile set. So again, that's where we're using this contains global ID. So for each tile set, we run the method contains global ID, passing in the global ID that we've been given. And if that comes back as true, which means that the particular tile set we're on does contain that global ID, then we return that global ID. Sorry, we return that tile set. As in, yep, that global ID exists in this tile set, here's the tile set. And then from that tile set, we can then go and retrieve information like the first GID and etc., the tile set ID and so on. If we get through all of these and we don't find that particular global ID in any of our tile sets, then we send nil. The next method is our render method. Okay, so what we're doing here is we are taking a point, which as I said is a point on the screen where we want to start rendering our map. We then take in an X and a Y coordinate, which is a map X and Y coordinate. Okay, so a tile X and Y coordinate within our tile map. We take a width and a height, which is from that X and Y tile map coordinate, how many tiles wide and how many tiles high do we want to render. And we then take in a layer ID. So in other words, we're saying on what layer of that tile is it that we want to render. So by doing that, the first thing we do is we grab a layer from our layers array for the ID that's been sent in. We then go and set our X and Y coordinates based on our point.x and point.y, because we're going to updating them, sorry, as we go through. And then we set our current quad to be 0 because we're going to be accumulating a quad. So one quad is one tile. So as we go through here, we're going to be incrementing the number of quads that we've actually had to create, therefore we can then manage how many quads should get rendered on the screen. The next bit of OpenGL is used to switch on our texture 2D, switch on blending. It then enables a couple of client states. One is telling OpenGL that it's going to be using, it should look for a texture inside the texture coordinate array because a texture should be rendered in our quad. And it's also telling OpenGL that to get the information about what quad to draw, the vertices are actually located in the vertex array. Okay, now what we will need to do is make a couple of little changes. In fact, no, these actually should be okay. I'm just thinking out loud here that I know there's a couple of changes we need to make, I believe, because of the way that the rendering is done. So because at the end of this rendering routine, I switch everything off. There are a couple of other areas inside image.m where we need to just adjust the rendering there so that some of those things I switch off are switched back on again. Because I'm sort of being a bit neater in this method and making sure that OpenGL settings are switched off after I've rendered and used them, because the next item may not need them. So in between, each rendering routine is responsible for switching on the OpenGL states that it needs, and switching them off at the end. Okay, so we don't end up with any funny effects because we're mixing states that weren't anticipated. We then loop through the tile set. So remember that for any one layer, there could be multiple tile sets in that layer. So the first for loop we set up here is to go through all of the tile sets that have been identified. What we then do for all of the tile sets is we say, well, we know that we're going to be only drawing, and to speed things up, we're only going to be rendering tiles to the screen from the current tile set. Okay, so what I can do here by doing this is it means that I can go through the first tile set and I can set or bind the texture to whatever the image is for that tile set. And I can then loop through, and when I render a tile, it will only render something if it belongs to the tile set for which I'm processing. And it means that I'm not having to do lots of bind textures. So rather than saying tile 1 comes from tile set 1, so bind the texture and then draw it, and then finding that tile 2 comes from tile set 2 and having to then do another bind texture and draw it, that's going to be pretty slow. So what I do here is I say bind the texture for whatever it is for tile set 1, and loop through the entire layer, but only rendering what's in tile set 1. Then loop through the entire layer again for the next tile set, only rendering what's for that. So you only set and bind the texture once for each tile set that you render for a particular layer. I hope that makes sense. So what I'm doing here is I'm saying get the texture name, which is actually being taken from the tile set we're processing, and tiles, okay, which is going to be the actual image inside it. Inside that we have an image, okay, which is going to be our sprite sheet image, inside which we have the underlying texture, which is our texture 2D texture, and underneath that we have our name. Okay, so it's a little bit of a long-winded method call there, but we're basically getting our texture name, which we're then binding. I then loop through the tile map here, and there's no particular reason for the order in which I'm doing this, but I'm starting by looping from yeah, so I'm sorry, mine went blank there. So I'm starting by identifying that map y is what I've passed in, so that's where I'm going to start, and I keep going as long as map y is less than map y plus height. Okay, so I'm literally going top down, and for each row, because that's basically each row, I then process each column, which is the x. Okay, which again I'm saying start wherever map x is, but only run from map x to whatever the width is that I've passed in, just like I was doing for the height. I'm then doing a quick check which says if the tile I'm trying to render is less than 0 or greater than the height and the width of the map, it means it's out of bounds. Now what I do here is nothing. Okay, so I don't try and render anything because I can't render anything. The tile is out of bounds of my map. But what you'll see a bit further down is that I still, okay, so here's our if. So down here, at the end of our if, I still increment the X tile location, okay? And what that means is that you can, if you're scrolling your map around, you may want to smoothly be scrolling left, right, up and down using the accelerometer, something like that. And that means that you may actually, because the width and the height of your map is constant, it's always the width and height of the screen, but you want the far right hand side of your map to be rendered all the way on the left hand side of the screen, you need to be able to render dead space. In other words, you need to be able to handle the fact that you're going to be accessing tile elements that are outside your map boundary. So that simple check does that. It just says, yeah, I'm going to increment my tile X, but I'm not going to try and draw anything because I'd get errors because there's nothing there to draw. If you are rendering a tile which is within your map boundary, then what I do is I go and grab the tile ID that was necessary. So again, I use the current layer and I say, get me the tile ID at a particular X and Y coordinate, which is where we are at the moment in our loops. And I then go and get the tile set ID using the same call. We're using an X and a Y. Once I've done that, I then check to say, well, for this tile, does it have a tile set ID that matches the current tile set I'm processing? So this is the check I was mentioning earlier. If the tile set ID for this tile is a match for the current tile set that I'm processing, it means that the image for this tile is going to be in my currently bound texture, so I can render it to the screen. If it's different, it'll just get skipped, okay, and it'll get picked up when we go through the appropriate tile set for that tile. So here, if we do find that this is the right tile set, then I go and populate my texture coordinates for the current quad using the get texture coordinates for sprite method, which we implemented earlier in our image class. And I then do the same for vertices for that current quad. Okay, so we then, using the X and Y information for our texture coordinates, and then using the same kind of information for our vertices, we're able to populate those two arrays. Once I've done that, because we've just gone and added a quad to our arrays, we then increment quad, okay, ready for the next time we loop around that. Once we've done that and we've added that particular tile, we then increment X, okay, so we say X now, which is the X location on the screen, is incremented by tile width, so we move over that much of the tile, and we loop around again. Once we've got to the end of our row, we obviously then jump down a row. So what we do is we say Y minus equals tile height, so we're going down the screen by the height of a tile, and we then reset X to be wherever X was initially, okay, which is why we took a copy of point.x and weren't updating it directly. And that's it, we just keep whizzing round, and eventually we'll end up with arrays, textural coordinates and vertices arrays populated with the quads and their associated textures ready to render. And because we're using draw elements, all we do is we identify that the vertex pointer is going to be this vertices array, that the texture coordinate pointer is going to be taken from the text coords array, and we then issue the draw elements command, which, using the indices, which is our array of indexes into these two arrays, which we described when we were doing the angle code font side of things, and the number of quads, it just literally just takes that information and flies through and renders them to the screen, which is much quicker than doing the individual calls. Once we've done that, for that tile set, we then reset X and Y again, back up to the top left hand, or back up to whatever the location is that you've defined, and we then go through the same process again, but for a different tile set. So, as you can understand from that, having multiple tile sets is quite handy and makes things easier to manage. But if you can get all of your tiles into one tile set, you're going to save quite a bit of work. Because at the moment we're having to, if there's multiple tile sets, we're having to scan the layer multiple times to identify what tiles to render for each tile set. If you keep all of your tiles on one tile set, then you only ever have to go through that layer once. And that obviously is a lot quicker. So just a tip there. And then when I'm finished, I then make sure that I disable everything I enabled earlier on. And that's it, the rendering is done. We've now rendered our tile set to the screen. And then we just have a last couple of methods here. One of them is saying I want to get the index of a layer by using its name. So because we read the name in, I'm able to just loop through all of the layers inside my layers array, checking to see whether the name that's been provided matches the name of that layer. And if it does, I return the layer ID. If none of them do, I return -1, which identifies that nothing was found. And then here I'm doing the get property commands. Okay, so remember we process the properties, which are those name value pairs, so that for a map property, if I pass in a string, okay, which is the key and the default value, what it'll do is it'll say, okay, go and grab the value of that property by looking in map properties dictionary and getting the value for the key that I've passed in. Okay, so that's quite a handy use of dictionary there. If the value is empty, okay, which means it is blank or it couldn't be found, then return the default value, which you've defined, or return the value of that particular map property. It's exactly the same for layer, although you're passing in a layer ID, so it knows which layer to suggest. And so I do a quick check here to say, well, if you're passing in a layer ID that's less than 0 or greater than the number of layers, then it's wrong. So it just gives you an error rather than getting some other kind of weird effects happening. But how you get the actual key is pretty much identical. And then the same for the tile property global ID. Okay, it's slightly more involved here because I'm having to convert the global tile ID number into a string, but I'm still doing the same kind of process. I'm going and identifying a value from a dictionary using an ID and using a key. And then lastly, we deallocate everything. So we deallocate the sort of raw C arrays that we created, because that's C, using the free command. and we also released tile sets and layers, which are the two items which we allocated, which can now be released. And that's it. So that's quite a long class there, but that's the actual real heart of how do we actually render a tile map. So I'm going to save that. But the next thing that I need to quickly change, as I said, is I need to just update the rendering routine inside my image class so that I switch things on and off as I need to. So if I go into the image.m file and go all the way down to render at, okay, the first thing I need to do is I need to add an enable client state here so that I enable vertex arrays, because inside my routine to render a map, I actually switch off vertex arrays at the end. So I need to re-enable them here to be able to do this. Now, I also want to make a change to this little piece of code just here. At the moment, this was a bit of a hack. So what I did was, so that I only changed and rebound to a different texture if the texture for the current image I'm about to draw changed, to sort of keep the speed up, I was actually holding the currently bound texture inside my app delegate as a property. That's not a very good idea. So we've actually, if you look onto the on the comments on the blog, you'll see that Jamie on there is actually identifying that that isn't a good idea to do that. It sort of breaks the model view controller pattern. And I agree, I wasn't really happy doing it, but it sort of just gave me a fix at the time. What I've been able to do is identify, again, Jamie's come up with this this great little find, which I tried to find and couldn't, but he's actually found it for me, which is great. And what it is a piece of code which allows me to actually ask OpenGL what the current bound texture is. So I'm going to place that bit of code in here now to replace this if statement in there like that. So what I'm able to do is I'm able to use this get integer value, and by passing in the binding 2D, and actually by putting the result inside this int that I'm defining here, I'm able to actually say what's the currently bound texture name. And that means I can do a very simple check, which is get the name of the texture I'm currently got bound, check it against what is bound here, oh sorry, the name of the texture I'm about to draw, check to see if it's the one that's already bound. If it is, don't bother binding it again. If it isn't, bind to that new texture name. And it saves me having to do that call out into the app delegate, which wasn't really a very, very good idea. So that was the second change I wanted to make inside my image routine. And then down the bottom here, where I disable a bunch of things, just to sort of clean things up a little more nicely, I'm going to add in here the fact that I want to do a GL disable client state, and it's going to be my GL vertex array, like that. Now I'm going to do a build now, make sure that everything actually builds okay, which it does. Good. So we haven't introduced any sort of simple errors that could be identified anyway. So that's the image class changed, and we now need to also make sure that our angle code font is updated as well, because there are going to be drawing elements on that, which again we need to make sure we're updating. Otherwise we are going to get some things that that go missing. So I'm going to just change my enable up here to make sure that it's enabling everything that should be enabled. Okay, so we've added an extra one in there, which was around the vertex arrays. And then I scroll down to the bottom and we make sure that we are disabling everything that we need to disable. Okay, after we've done our draw. So just paste that in there. Good, build. And that's it. So if I run the project now, I hadn't changed my device to simulate, so you'll see there that I had to quickly pause the recording and not have to put you through me loading it to my iPhone. So right, as I was saying, I'm on the simulator now, so I want to run what we've written, and we should literally just get exactly. So that's exactly what we were getting when we were when we got to the end of our tutorial 5. So we want to add a tile map to that. Okay, so I'm going to stop that running. And if we drop into the EAGL view.m, we can actually add here. So just change this to say init tile map. Okay, so if I drop back into my code, there's a few parameters that I want to create in here. So one, oops, I need to first of all go and import my tile D class that I've just created, which is there, and I'm going to say tile D map is going to have something called tile map, and I want to store a couple of extra bits and pieces on here of things that are going to be useful. In fact, that's probably all I need to do for the moment. So save, flick into the main one here, and I'm going to say tile map equals tile D map allocate init with, and what I'll do is I'm going to have that test map. Okay, so test map is the name there, and the extension is TMX. Okay, so just build that, make sure we're okay. Yep, so that's the tile map actually loaded. So we've got the tile map in place. What I want to do, actually, I'll flick back to my heading here, and I'll have something called CG point, and I'll call this map point, which is going to be the location I want to render the map. And then I'm going to have something else here called tile map x. Oops, int tile map x, and that's going to control the x position in tiles that I am in the map as well. So save that, drop back down, and I'm going to say that my tile map x equals, let's say, -8. Okay, because I want to render the map off the right hand side of the screen, and I'm going to scroll it from the right hand side of the screen to the left. Okay, so we want to do that. So again, you can see having a minus number here means I'm outside the bounds of the tile map. But that little bit of code that we used to check to see that we are in and out of the bounds means that it doesn't matter. It's not going to blow anything up. It will quite happily render and position everything properly on the screen by doing that. Okay, so that's our little bit of setup there. In fact, I will also set here my map point. So map point dot x equals 0, and I'll say map point.y equals, now these tiles are 50 pixels by 50 pixels, so I'll do my 480 minus 50, so I'll say 430 is where map y is going to be. So scroll down a little bit, and I'll do a little bit of updating inside my game logic. So what I'm going to do is I'm going to say map point.x minus equals 0.1 times delta. So I want to move the map to the left. So I'm moving where the map is actually being rendered to the left. So the actual whole map will scroll to the left. What I'm going to do here is I'm going to say scroll the whole map to the left. When it's scrolled one whole tile width to the left, I'm going to increment the tile x position from 0 to 1. I'm then going to reset the map point.x file back to 0 and then carry on again. So literally the map will just continue to move from right to left, but I'm only ever drawing pretty much what can be seen on the screen of the map. The rest of the map isn't getting rendered. Okay, so that's the effect that I'm looking for. So I've done my map point there, so I now need to do my check. So I can say if map point x is less than the negative width of a tile, so I can then say tile map tile width, like that. Then I'm going to do a couple of things. I'm going to say map point.x equals 0, so we reset the rendering location of the map, and we say tile map x plus equals 1, so we increment that. Now we also need to do a check here as well. I don't want, if it gets to the end of the tile, I want it to just jump back to the beginning again. So I can then say if tile map x is greater than, what we can do here is we can say tile map map width. Okay, so again, that's the width in tiles. So again, we're just grabbing properties that have been identified and loaded as part of a tile map. Then we set tile map X back to 0. Okay, or sorry, back to -8. That's what we had before, wasn't it? Okay, like that. So build that, make sure we've got nothing in there. We've got 12 errors in here. Okay, I've gone and missed something out. Yes, I have. I need to go and pop in a bracket there. Let's build that. That's better. Okay, so that's now got the game logic up and running. So now what we do is we actually add the rendering. So I'm gonna render this first. So the tile map is the lowest thing on the screen, and everything else will render over the top of it, which would be quite cool. So what I want to do is I want to say on my tile map, I want to render at point. Now map point is the location I want to render at. Okay, I want to map X is going to be tile map X. Do that. Map Y, I'm going to say 0 for the moment. Width is going to be however many tiles it takes to fill the screen in terms of if it's 50 pixels, how many do I need to fill the screen? So I'm going to say we want 6 here. And I'm going to say 10 for the height, like that. And I'm going to say layer 0. This map has only got, well, it has got 2 layers, but I only want layers 0 to be rendered. Okay. So that's the rendering command. Okay, that's going to render my map on screen, hopefully. So if I build that, make sure nothing comes up, and we'll run and have a look. Okay, so we're not getting anything rendering there. So let's have a look and see what I've gone and done wrong. Okay, so the reason why that wasn't working is that I need to cast these to ints. I don't fully understand why I need to do that at the moment, but anyway, it doesn't matter. So I'm going to just cast those 2 properties that I'm reading there to integers, and I'm going to save that, and then we're going to run again. We should be seeing, and there we go. So we've got the tile map scrolling from right to left on our screen, which is exactly what I was after. Excellent. So that shows you what we can do with the tile map. I mean, just to show you that's something that we can edit. If I start that again, okay, as it comes through, you'll see we've got sort of like a block work here, and then nothing else. What I'll do is we'll just edit the map to make that slightly different. So if I open this, and I won't save anything on that. So if I go into desktop, tutorials 6, we open up test map. There we go. So there's the map that we're just scrolling through at the moment. So if I grab one of the, yeah, if I just grab that, pop it in there. Okay, so this is not transparent. So there you go. So I've gone and just made some changes to the tile map. I'm going to scroll along here. I'm going to add a few more bits and pieces. Okay, so I'm just literally clicking around in here, adding tiles that I want. I then save that, go back to my project, and then run it again. And we should see those tiles now, there we go, properly identified inside my tile map. So that's how easy you can edit the tile map. Obviously you can do the layer side of things as well, as you need to. So if I stop that particular one and I go back to my tile editor, okay, and let me erase some of these things here. Let's put this bit of floor back. Oops, got the rubber still on. Put a bit of floor back. And you can do all sorts of things in here. You can fill, you can highlight, you know, all those sorts of things. So what I'm going to do is I'm going to create a new layer here, and inside that new layer I'm going to highlight this, and if I put it down, you'll see that it's now sitting on top of, because it's transparent, it's not just deleting what's underneath it. Okay, so I'll just do that. Put that in there, just so we've got some of those things. Maybe one over here. Okay, so if I save this map, all right, and I go back to my project and run it again, you'll see they won't appear. Okay, because I'm only rendering layer 0. So if I stop this, I go down into the render routine, if I copy that and I actually then say, right, I want to render layer 1 as well, and we run it. Okay, there we go. We can see that I'm now rendering the first layer, which means that those icons are now being put on there. So it's quite cool. There are things you may want to render 1 minute and not render at all the next. And so you have the ability to do that by using layers, which lets you make those sorts of changes. You could also achieve parallax scrolling, not using layers, but you could have, you know, a bit like I've got here, the text is moving faster than the background. So that's like a parallax image. So you could have a tile map which is designed that maybe you have the one in the back is moving a little bit more slowly than the one close towards you, and giving you that parallax, that sense of distance when you're actually doing these things. So it's a pretty cool class. I'm pleased with it. It's come together well. The performance isn't bad either, but it really should allow you to create some quite nice maps. And as you can see there, what we did is I got to the very right hand side of the map, it scrolled around and it started again. So this could be a level, this could be some kind of space level or something that's moving. Now in the next set of episodes I'm going to also cover having the phone in landscape mode like that, which at the moment you can see obviously doesn't make any changes, but obviously what I want to do is have things moving from left and right and making use of the bigger landscape mode. There's questions been on the comments and about that. And again, it's also something that a lot of other games seem to use, and it makes sense. So that's something which I will get sorted out as well. But hopefully that's given you some idea of how to use the TileD map class. The last thing I will actually show you before I go is back into the editor and how to set properties. So for example, I've set a map property here. So if I go into properties for my map, you can see I've set anything I want, and I can call this my map prop. And the value is going to be my value. Okay, so you can really set anything you want, and I'll save that. So then I'll save that particular map. Okay, drop that back down, and then inside EAGL view, I'll just go and output that value after I've picked up my tile map. So if I do nslog, and I'll say map property value equals, and it's a string that's going to come back, and what we're going to do is we're going to say tile map get map property. The key is my map prop we used, and the default value is going to just be default if you can't find it. Close square brackets there like that. Build, it's done. If I run that, okay, it won't make any change to the screen, but if we look at the console, okay, we can see here, well, one, we can see some of the information that gets output at the moment by the tile map parser. Okay, so we can see here that as we were actually processing the tile map, it did find a property called my map prop with a value, and I've just gone and grabbed that value, and we can see there's my output here. Okay, and we can see that there are 2 layers that were found. Okay, and we can see that each layer had 600 tiles in it. There is a performance hit here. I mean, the biggest tile map that I've done is 20,000 tiles as a test. That's 2 layers of 10,000 tiles. And on a real iPhone, it takes around about 5 seconds to load and pass that size of file. So you start to get much bigger than that, and I think you're going to notice quite a hit on the old performance. But keeping these sorts of tiles, I mean, the one that I'm doing at the moment, you can see it's 100 tiles wide and 6 tiles high. It's a long one. And that loads very, very quickly. Obviously, you can't use these times in the simulator as a guide, but it does load very, very quickly. So there we go. The grabbing the properties is the same for any of the other properties that you may be setting. And it's really just a case of have fun. It is a very useful, it's a very useful class. It's certainly going to be something I'm going to be using in whatever the game is that I come up with at the end of these tutorials. But I hope you enjoy it. Let me know if you have any problems. As always, the project has been uploaded onto the website so that you can grab hold of that. So let me know what you think, and I will be speaking to you soon with my next tutorial, which should hopefully be my particle system. So I've finished the particle system. It's very basic. It's based heavily on the particle system that has been developed as part of Cocos 2D, which Rick over there has been very kind to sort of share some information about. Obviously, it is open source as well. But that's it may be simple, but it certainly can give some very cool effects, even being simple. So that's going to be the next tutorial, which I'll do as soon as possible. So stay tuned, and I'll join you again shortly. So thanks very much.